Hi everyone, today we're going to be talking about triangles. Just a reminder, make sure that your notes page looks just like my page and that you are copying down whatever I write on the screen so that you have it to look back at. First, let's just do a little bit of review. Triangles can be named in two ways. One way we can describe them is using their angles, and the other way is using their sides, and sometimes both. So if we're looking at how we could name triangles by their sides, if all three sides are the same, we call that an equilateral triangle, which kind of sounds like what it means, right? Equal means it has three equal sides. If two sides are the same and one side is different, we call that an isosceles triangle. And if all three sides are different, no equal sides, we call that scalene. The more common way you're going to see it is by naming triangles by their angles. An acute triangle has three angles that are less than 90 degrees. It's all made up of cute little angles. That's how I remember it. A right triangle has one angle that is exactly 90 degrees, and we use a little box symbol in the corner to show that. It is 90 degrees exactly, and that's really important to remember. And then the last one is an obtuse triangle, where one of the angles is bigger than 90 degrees. Some general reminders: no matter how the triangle is classified, no matter what name it is, all triangles, no matter what, always add up to 180 degrees when we add up all three angles. Another thing you might be asked to do with a triangle is a right triangle is to find the measurement of one of the sides. If we are missing the side measurement of a right triangle, we can find it using a squared plus b squared equals c squared. And I'll show you some examples of that, so don't worry. And that's called Pythagorean theorem. And then finally, to find the area of a triangle, we plug into our calculators 1/2 times the base, which I think of base bottom of the triangle, times the height. The height always makes a 90-degree angle with the base and goes up to a vertex, okay? So notice this can't be the height because it does not make a 90-degree angle with the base of our triangle. The height has to make a 90-degree angle with the base of the triangle. Sometimes you have to turn the triangle or imagine turning the triangle in order to put the base at the bottom, but that will definitely help you remember and figure out which side is the base and which side is the height. So let's look at how triangle problems will come up on your progress monitoring. The first kind of problem shows you an example of a triangle, and it says, what is the measure of angle BCA? If you trace your triangle starting at B and going in that order, B, C, A, you can see that the angle they're talking about is this one here that's labeled with that little square in the corner. If you remember, any triangle with that square in the corner, that angle always means 90 degrees every single time. This time, they're asking you to identify the height of the triangle. So if you remember, the base is always the bottom of the triangle, and the height has to make a 90-degree angle with the base. So line S does not make a 90-degree angle. Line Q does not make a 90-degree angle. The only one that does is line P. We can tell because it's labeled with that box in the corner. So that means line P is the height of our triangle. In the next example, they give you the measurement of angle B, 36 degrees. They use that box symbol, so we know that the measure of angle C is 90 degrees. And they want to know, what is angle A? Well, if you remember, all three angles of any triangle always add up to 180 degrees. So we know that all of them put together are going to equal 180. So we can write ourselves a little equation. 36 plus 90 plus A are going to add up to 180. So first thing we can do is add 36 and 90. This equals 126. So 126 plus something equals 180 degrees. Well, in order to figure that out, we can use the opposite operation and subtract. We can subtract 126 from 180 to find out what that missing piece is. And we're going to see that angle A equals 54 degrees. The next kind of problem you might see on your progress monitoring has to do with that Pythagorean theorem or finding a missing side. And it's similar. We are going to just plug our numbers into this formula and then solve it like we would any other equation. The tricky thing about this one is that it uses the exponent 2. So I'll show you what to do with that. So a squared plus b squared equals c squared. The first thing you have to know is that your base and your height of your triangle are always A and B, and it really doesn't matter which is which. Whatever is across from that 90-degree angle is always C. So in this case, we have 18 squared plus B squared, that's the part that's missing, equals 30 squared. Now it's helpful to find the squared button on your calculator, but you can also just type in the base number times itself. But if I type in 18 squared, I'm going to get 324 plus b squared. And then if I type in 30 squared, I will get 900. And then we're going to solve it like we would any other equation. So opposite operations, I'm going to subtract 324 from both sides. And now what I have is b squared equals 576. So now you have to know what's the opposite of squaring something. It means I have some number times itself that's going to equal 576. But to find that, what I want is to take the square root of it. So squaring a number and finding the square root of a number are opposite operations. So that cancels out. And if I plug into my calculator the square root of 576, then I will have my answer, my missing side. When I do that, I'm going to get 24 as my answer. The next example says one leg of a right triangle is 9 units long. The hypotenuse of this triangle is 41 units. The hypotenuse is that side across from the 90-degree angle that's C every time, right? So 41 units long. What is the length of the other leg? So again, I'm going to plug my numbers into our formula. A squared plus b squared equals c squared. And then I'm going to solve what I can. 9 squared is 81. So I'm going to fill in 81 plus b squared, and then 41 squared is 1,681. So again, I'm going to use opposite operations. I'm going to subtract 81 from both sides. And I'm going to have b squared equals 1,600. And the opposite of squaring a number is to take the square root of it. So I'm going to do that to find out what b is. And the square root of 1,600 is 40. I can check because 40 times 40 equals 1,600. And that's my missing side. Go ahead and work on the you try it problems. And again, I've grouped problems that are similar together on a page. Please go back and re-watch the examples, especially of those Pythagorean theorem ones, when you get to that part. And then if you need extra practice, there are links for you at the end of the slideshow. Happy practicing!